Everyone, in this part, we're going to talk about using our combinations in order to do things that talk about at least or at most or something like that, where they give us kind of an inequality style um, writer here. So, for example, suppose a coin is flipped 3 times. The coin can show heads 0, 1, 2, or 3 times. To find the number of combinations with at least 2 heads, we simply add the number of combinations with 2 heads and the number of combinations with 3 heads. So in this case, again, let me talk about, like, I like to draw out the heads and tails. So you could have heads, tails, heads, tails. So we flip a coin 3 times. We could get heads or tails the first time, heads or tails the second time, heads or tails the third time. If I were to ask to find the number of combinations with at least 2 heads, right? So I basically am saying, okay, let's choose of these flips, right? This is flip, 1, 2, and 3. I need to choose 2 of them to be heads, right? That's what we're getting at here with our choose notation. Which 2 do I want to be heads? Well, we just need to figure out how many possible combinations there are. So that's why it's 3 choose 2, because I'm choosing 2 of these 3 to be heads. Similarly, could all 3 of them be heads? Yes, to meet the condition at least 2 heads. So I could do 3 choose 3. So that's the rationale behind doing this. Okay. Side note, I know it's a little confusing because here the order seems like the order matters, but trust me, it actually doesn't, because we're choosing which we just need to figure out which of these 3 we want chosen as heads. And even though they're indistinguishable coin flips from each other, we do need to separate them out as different possible combinations. Okay, so this one has a coin being flipped 5 times. What is the probability the result is heads at least 4 of the 5 times? So again, I'll write it out. So we have heads, tails, heads, tails, heads, tails, heads, tails. So the total number of outcomes in the sample space, again, is 2 to what power?
I'm sorry, I'm totally spaced out.
So we have 5 coin flips, and each one has 2 possible options.
Okay.
So the total possible outcomes for our entire sample space is what?
2 to the 5th power.
Yes, which is 32. Good job. And then we just need to narrow it down. This is our denominator, right? The sample space is our denominator, so we need to figure out the numerator, which in this case, we can use our choose notation to figure out. Event A is that the coin shows heads at least 4 times. So at least 4 means it could show 4 times or what?
Or 5.
Or 5. Yeah. So we're going to just add those 2 probabilities up. The probability that it comes up all 5 heads, how many possible ways can we arrange these coin flips so we get all heads? Well, there's just one way, right? It's heads, 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 heads. So the way we're going to calculate that here in the book that it's given is we're going to do 5 choose 5, right? We're going to choose which 5 of these 5 do we want to be heads. Well, there's only one way to do that, so that's equal to 1. We also need to add up all of the possible combinations where we get 4 heads, right? So we need to choose 4 of these 5 to get heads, to come up heads. So in that case, it's 5 choose 4 combinations, which is what? What's 5 choose 4 combinations?
5 factorial divided by...
You can cheat, it's okay.
4. I'm trying
4
not
factorial
to.
and 1
4
factorial.
and 1 factorial.
Okay, 1 factorial is blah, blah, blah. What's 5 factorial divided by 4 factorial?
1.
Not quite.
No.
Again, you can do this in your head.
What's 5?
No, what's 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times... Yeah, it's just 5.
It's 5.
Right, because all of these cancel each other out, blah, 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 blah. So 5 factorial divided by 4 factorial is 5. So you don't even need a calculator for that. You should be able to just jump right to 5. Again, 5 factorial divided by 5 factorial, this becomes 1, disappears, is simply 1. So 5 plus 1 is 6. So our grand total for this whole probability business is 6 out of 32, which again could be reduced or fractionized or decimalized or whatever you want. But 6 out of 32 possible. Okay, let's try a couple more. 3 number cubes die are rolled and the result is recorded. What is the probability that at least 2 of the die show a 6? So again, we can think about the number of possible outcomes. These ones are a little bit different because instead of being you can think of die as just coins with 6 sides, right? You flip the coin with 6 sides. What is the probability of, how many options are there for the first die?
Sorry, I was keeping.
How many options are there? How many options are there for the first die?
6.
How many options are there for the second die?
Also 6.
And the third die?
6.
So the total possible number of outcomes is what?
6 factorial. Oh,
No, it's
no.
not. No, this one is, so there's 6 for the first, 6 for the second, 6 for the third.
Okay.
Just
So
like we do with the
it's
coins.
just multiplication.
Yeah.
It's not factorial.
So it's what?
6 times 6 rolls. Am I doing?
No, just 3 rolls.
3
3 rolls
rolls.
of a die.
6 times 3 is 18. It's not.
It's 6 for the first one, and then let's say I get a 1 on the first one.
Okay.
How many ways can I get on the second one? How many
Also
different outcomes?
6.
I could also get 6 different outcomes there, right? Let's say I get a 1 there. How many options do I have for the last one?
Thought I wanted to get 2s.
2's later.
Okay. Okay. So the second one.
What did we do with the coin flips when we did coin flipping?
Exponents.
Yeah, let's say I flip a coin 3 times.
Okay.
What would that be? How many possible outcomes are there?
6 to the third.
No, just a coin flip. Coin flip. Heads, tails.
Wait.
Heads, tails. Heads, tails. I can write these out. Watch this. Here's my options. Heads, 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 tails. Give me an answer before I finish.
I'm not sure what you're asking me.
How many possible outcomes could I get if I flip a coin 3 times?
If you flip a coin 3 times, and this is a 2-faced coin, not a 6-sided die.
Greg, I'm about to meet you.
I'm getting flustered again. Did you beat
Did I
me
miss
here?
one? How did I miss one?
I don't know.
Did I get them all? I don't know.
So
Hold on.
wait, we're flipping a coin now.
I'm trying to simplify the thing so we can extrapolate to a larger example.
Okay.
So if I flip a coin.
Okay. Flipping coins.
I messed that up.
Heads
No.
or tails?
No, I got that right. Okay. Just for the record, that was right. I erased it, but it was right.
Yep.
I beat her. Okay. I flip a coin 3 times.
3
Okay.
times.
First time I flip it, I get heads or tails.
Right.
Second time I flip it, I could get heads or tails.
Okay.
Third time I flip it, I could get heads or tails.
Okay.
So how many different patterns of coin flip could I get?
Patterns?
How many different possible outcomes could I get?
6. Heads, tails, heads, tails, heads. 6. I'm not.
You remind me of some of my
math.
students.
Okay.
No, you're good. You're fine. You can handle this. Okay.
So not 6.
The first time you could get heads or tails, right? So let's go down this little logic. Let's look at a little tree. Okay, we'll do it like a tree. So here at the beginning, we'll do heads over here on the left,
Okay.
tails over here on the right.
Mm-hmm.
So the first flip, I can go toward heads or tails. Which way do you want to go?
Heads.
Well, let's say the other way is tails.
Okay.
Right? We flip it again.
Okay.
Which way do we want to go?
Tails.
Okay, but we could also go toward heads.
Good.
Which way do you want to go here? Toward heads or tails?
Tails.
Tails. Okay, but we could also go toward heads.
Okay.
So your possible outcome, the one you chose here, was we go heads, then we go tails, then we go tails.
Okay.
We could also go heads, tails, heads.
Okay.
Right? We could also go heads, heads, what?
Heads, tails,
Heads. Or it could go heads, heads,
tails.
tails. What if we did tails first? Let's get be crazy
Whoa.
here.
Okay.
Tails,
Heads, tails,
heads, tails, or tails,
heads, heads,
heads, heads, or tails,
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 tails, or tails, tails,
heads.
heads. Good. Whew, we made it. All right. How many possible outcomes are there?
8.
4, 5, 6, 7, 8. Yes, there are 8.
You said it wasn't exponents.
No, I didn't say it. No, I said it wasn't factorial.
Okay.
So there's 8 possible outcomes for flipping 3 coins.
Okay.
Right? So how do we calculate 8 as opposed to drawing a tree every time?
We do 2 to the third power.
Yes, 2 to the third power. Now we want to extrapolate the dice. We have
Okay.
3 die.
Okay.
We're going to roll the die. There's 6-sided die. How many possible outcomes are there?
How many times am I rolling it?
3.
So it would be 6 to the third.
Yay, which is? You're still on calculator duty, go. Video's not supposed to be this long, by the way.
216.
She made it long.
I'm sorry.
No, it's probably a good question because someone else probably got confused. Okay, cool. 216.
I'm really not good at math.
So let's back up again. We're rolling 3 die, and the question is, what is the probability that at least 2 of the number cubes show a 6? So how many of these die could show a 6? Could 1 show a 6?
Yes.
No, that doesn't work. It says at least 2.
Oh.
Could 2 show a 6?
Yes.
Could 3 show a 6?
Yes.
Could 4 show a 6?
Yes. Yes. Is there an at most?
How many die are being rolled?
3.
3. Haha, I got you. So we only need 2 or 3 die, right? So we're going to do 2 separate calculations. One is for if there are 2 of them that show a 6. The other one is if there are 3 of them that show a 6. So blah, 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 blah. We did that. Again, oops. Okay. So think about it this way. It doesn't really matter what my first one is if I get a 6 on the next 2, right? But the question is how many if I have 3 die and I need to choose 2 of them to have 6s, how many ways could I choose that? That would be n choose r, which is n is what? How many things am I choosing here?
3.
Yeah, I'm choosing 3, and I'm choosing how many of them to be 6s?
At least 2.
Yeah, 2. So that's 3 choose 2 combinations. So that's 3 choose 2 combinations. And then of those 3 choose 2, what are my possible outcomes for that third die? I could get a 1 or a 2 or a 3 or a 4 or a 5 or a 6, right?
Okay.
So I'm going to multiply that by 5. So this will give me the total number of possible combinations. So
why are we multiplying it by 5?
Because I could get 1, 6, 6.
Okay.
Right? I could get 2, 6, 6. I could get 3, 6, 6. I could get 4, 6, 6. I could get 5, 6, 6. Right?
Okay.
All of these are just as likely. This thing's going to return my 3 here. So I could also get 6, 1, 6, 6, 2, 6. I'm writing all these out. 6, 3, 6, 6, 4, 6, 6, 5, 6. Right?
Okay.
That's my second set of 5, and then my third set of 5 is 6, 6, 1, 6, 6, 2, 6, 6, 3, 6, 6, 4, 6, 6, 5. And the 3 choose 2 combinations covers my 3 options for where the 6s are. It could be x 6 6, it could be 6x6, or it could be 6 6x.
Okay.
And then I need to multiply it by 5 because 5 is the total number of possible options for that third one.
Right.
We get 5 because it's the number of things. Like a die has 6 sides, right? And then we subtract 1 because um, it can't be 666 because we'll cover that at a later one. So this third side has to be different than the 6s. We didn't have to factor it in with the coin flipping because there's 2 sides to a coin, and if it's not heads, it's automatically got to be tails. And we already assumed that it wasn't heads when we do these calculations. Similarly, we're assuming that the third one isn't a 6. Cool. So then we need to factor in one more, which is what? What's the last one? There are 3 of them show up as 6.
Oh, yep.
Right? 6,
Yes.
6, 6. Which it can be written as 3 choose 3 permutations because that's just 1. I'll plug all that in, add them all together. There we go. Gives us 16. So 16 is the number of elements in event A. 216 is our sample space. And the probability is simply 16 out of 216. Okay, let's try these two. So we'll pause here. Math department has a large database of true-false questions. When they say that, they're basically saying that you're drawing from an infinite pool. Kind of like how when you flip a coin, heads and tails, you don't run out of heads in the universe, right?
Right.
They're saying it's large enough so it's functionally you could draw an infinite number of trues and it won't like depress the population of trues where it's less likely to draw them. Half of which are true and half of which are false. That are used to create future exams. A new test is created by randomly selecting 6 questions from the database. Okay, so let's stop there. We won't even get to the probability part. How many elements are in our sample space? So
infinite?
We have true, false questions, right? So true, false. This is kind of like our coin flipping. True, false. How many are we selecting?
6.
Okay. So how many different patterns of true, false could we get?
2 to the 6th power.
2 to the 6th power. Good job. Ta-da! You got one right.
Just
don't
one.
look too surprised. Okay. So our total sample space is 64. Now we can do the use choose notation for the last one. So it says, what is the probability the new test contains at most 2 questions where the correct answer is true? So at most 2 means it could contain 2 questions where the correct answer is true, or what?
1.
Or 1, or
0.
0. Yeah. So we're going to cover all these options here, and we can simply write them out as how many questions total are there?
6.
6. And we're going to choose how many to be true?
0 or 1 or 2.
Yeah, so we'll do 0 plus 6 choose 1 plus 6 choose 2. We're going to add all those up, and that'll be our numerator. So 6 choose 2, 6 choose 1, 6 choose 0 adds up to 22. And so it's 22 out of 64. Good job. Oops. Okay, number 7. There are equally many boys and girls in the senior class. Same sort of deal. We just have to choose one or the other. If 5 seniors are randomly selected to form the student council, so we'll stop there. What is the sample space of this one?
5.
No, total sample space, the denominator. 5 seniors are randomly selected.
Okay.
And we're talking about boys versus girls here, right? So what's the boy, you know, because you have boy, girl, boy, or girl, boy.
You need at least 3 girls. So
No, we're not there yet. Ignore the probability part.
okay.
We want to figure out the total sample space. So we're figuring out the denominator for the probability question.
Okay.
So we're choosing 5 seniors,
Okay.
right? We'll do boy, girl, boy, girl, boy, girl, boy, girl, boy, girl.
Okay.
If 5 5 seniors are randomly selected to form the student council. So I could pick boy, girl, 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 boy, girl, boy, boy, girl, boy, whatever, right? How many possible ways are there to do this?
2 to the 5th.
2 to the 5th. Good, good, good. Okay, she's got it down now. 2 to the
Bless
5th. So now that we figured out the total sample space, we can zoom in here on this last part, which is what is the probability that the council will contain at least 3 girls? So how many girls could be on the council?
3, 4, or
3,
5.
4, or 5. Yeah, those are right. We'll do prettier ones. 3,
Ooh,
4,
beautiful.
not that much better. Okay, 3, 4, or 5.
Pretty good.
Girls. So again, which ones are going to be girls? How can I figure out the number of combinations there?
5.
Where n is equal to 5 and r is equal to
3 or 4.
sure. We'll start
or
with 3.
5.
So again, it's
So
5,
5,
choose 3,
3
plus
plus
5, choose
4
4 plus
plus 5, choose 5.
5. Yep. Which gives us blah 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 16 out of 32. Note here you can actually shortcut this one a little bit by noticing that, well, if there are 3, 4, or 5 girls, that means that there's 0, 1, or 2 boys. And having 0, 1, or 2 boys is the same thing as having 3, 4, or 5 girls. It's essentially the odds are equally likely, 50-50 for either one. So you can just jump straight to the fact that it's a 50-50 shot. I would accept that as logic, but either way you cut it, you get a grand total of 16 out of 32, or 1/2. Okay, that's it. That's all I got. Good luck on your problems.
Good night.